Today we're going to look at another foldable. We're going to look at family of functions. So you have your handout like this. So you can see I've already creased it along those edges. So that's what you're going to do. You're going to crease the edges so it's a trifold in like such, so that you have a trifold. The next thing I want you to do is you're just going to cut to the center crease. So you're going to cut out each tab just to the center crease. And we're going to do it on this other side here, just to the center fold. So we're going to investigate 4 different functions. There are many more than 4 functions, but these are the only 4 that we are going to concern ourselves with today. So if I close my trifold, the first one that we are all very familiar with is our linear function. And this happens to be the equation that I've chosen to do for my linear function. So when we open it up, we see on the left we have a table of values. We have our function graph. And then inside we have ordered pairs and mapping. So the first thing, let's just start with looking at our function here. So I'm going to get closer, zoom in, so we can see this bad boy a little bit better. Okay, so the first thing that we need to know that this is the same as y equals 1/2 x minus 3. But we write it this way because we're saying the function of f at x. Well, what is it? So the way I'm going to write it, I have my value of x here. So my function at -6 is 1/2 times -6 minus 3. Okay? So if you struggle a little bit with your calculator, with doing this longhand, you can always use your calculator. So 1/2 of -6 is -3. -3 and -3 is -6. So remember, this is my input, this is my output. So now my input is -4. So I have my function at -4 is equal to 1/2 of -4 minus 3. So 1/2 times -4 is -2. -2 and -3 is -5. So my input when x is -4, my output is -5. So now I'm going to do the 0. So my function when x is 0 is 1/2 0 minus 3. Well, 1/2 times 0 is 0. -3 plus 0 is -3. So when I input 0, I get out -3. And it's the same way all the way down. When I input 2, 1/2 times 2 minus 3. Well, 1/2 times 2 is 1 minus 3 gives me -2. Then I have my input of 4. So my function at x is 4 is 1/2 times 4 minus 3. Well, 1/2 times 4 is 2 minus 3 gives me -1. Now I have an input of 6. So f, my function, when x is 6 is 1/2 times 6 minus 3. Well, 1/2 of 6 is 3, minus 3 gives me 0. Okay. So before we go to the graphing part, let's look at ordered pairs, because this lends itself nicely to looking at ordered pairs. So when we're saying ordered pairs, we're talking about our x and our y coordinate. So this is our x. We put it into some function, and it spits out a y. So our ordered pairs are, I'm going to write it right here, our ordered pairs are -6, -6, -4, -5, 0, -3, 2, -2, 4, -1, 6, 0. So those are my ordered pairs, my input and my output. So another way that we can show ordered pairs is through mapping. So when I put in a -6, I get out what? -6. When I put in -4, I get out -5. So these arrows are important. When I put in 0, I get out -3. When I put in 2, I get out -2. When I put in 4, I get out -1. And when I put in 6, I get out 0. So these three ways, through a table, if I were to take out this middle bit, that would be my table, ordered pairs and mapping are all saying the same thing, along with graphing. Okay? So unfortunately my pen bled through a little bit, but we're just going to go ahead and we're going to graph those points. So my points are -6, so I go to where x is -6, and I get out -6. So -6, -6 is a point right there. I put in -4, I get out -5. So -4, I get out -5. 0, when x is 0, I get out -3. When x is 2, I get out -2. When x is 4, I get out -1. When x is 6, I get out 0. So hopefully those graphed a nice straight line. Okay, and it did. So then that means that this is the line. So I have just expressed my input and my output in 4 different ways. Via table, if we were to ignore this center part right here, where we did our work, that would be our table. Through a graph, through ordered pairs, and through mapping. Now, the only thing that's different with the line and with these other 3 methods of showing you the value of the equation y f of x equals 1/2 x minus 3 is that with the line, my solutions are not just these points. It's everything in red. So I have an infinite number of outputs and an infinite number of inputs. Okay. So the last thing that I want to do on this graph is I want to identify the 0 of the function. So the 0 of the function is where y equals 0. And this line here is where y equals 0. That's the same as my x-axis. Okay? So my x-axis is where y equals 0. So the 0 of the function is where I have my x-intercept. So I'm going to circle that x-intercept. I'm going to put an arrow, and I'm going to write 0 of the function. So that's the 0 of the function. And the 0 of the function, we're going to see that in all these different functions is something very important, especially when we get to quadratics. So that's the point on this particular graph where x is 6 and y is 0. So what I want you to do now is I want you to continue the same process with absolute value function, with the quadratic function, and with the cubic function. So if you notice the difference, all these equations look relatively the same, 1/2 x minus 3. Here we have 1/2, well here's my x, but it's inside the absolute value, and it has something happening to it inside the absolute value. This here is 1/2, well there's my x, that's inside a parentheses, and x inside this parentheses, this whole quantity is being squared. Here I have 1/2, well here's my x inside the parentheses. These look very similar, except on the outside of my parentheses I have a 3 for cubing. So you'll see that these graph somewhat differently when you graph them.